Welcome everyone. Day 4 of CES. Made it. I've actually almost lost my voice, so I presume CES is a success. Today we're going to talk about the key to powering a sustainable AI revolution. And my name is Ami Badani. I'm the Chief Marketing Officer at ARM. I've been on board for about a little over a year. I joined from NVIDIA, where I spent several years prior. And I'm super excited to actually have this conversation with my two partners, Sy Choudhury from Meta, who'll be joining me. And we're a close partner of Meta around everything from what we're doing with them around Llama, as well as some of our technology that's being used in the Meta glasses and so on and so forth. And Dion Harris from NVIDIA is actually a former colleague of mine. And he'll be joining us as well to talk about, we've had a long and deep relationship with NVIDIA and ARM. So we'll be talking a lot about sustainability and how we think about the power scaling challenges as it relates to large language models. So I'm just going to kick it off, frame a little bit of our discussion, and then have both Sy and Dion join me for a fireside chat and a conversation. See if I can get this clicker to work. All right, so I think, I'm sure every single session at CES has been some AI conversation. And so what I really wanted to talk a little bit about was, why I'm excited. I know there's been lots of conversations, speculation about where are we really seeing AI in terms of mass scale adoption. I thought I'd put up 3 data points that I thought, is exciting, and we're obviously still in our infancy about where AI is headed. The first one is around healthcare. It's really around drug discovery. And what we're seeing is that large pharmaceutical companies are using generative AI to really accelerate drug discovery. So you look at drug development, and really the most complicated, long process of drug development is all around R&D. So how can these pharmaceutical companies who are already using generative AI reduce the time to market for some of these drugs? So we're already seeing this, and there's a stat here that says 50% where pharmaceutical companies are already using large language models to reduce and accelerate their R&D investment to bring drugs to market faster. The second is around automotive, and I'm sure if you've gone to, I believe it's the West Hall, seen all of the autonomous vehicles that are coming to market either now or in the future. And what you realize is that every 24 seconds, a life is lost because of the amount of traffic collisions due to human error. And so autonomous vehicles, I believe, are really going to change this. And what I believe is going to happen is that you already see autonomous vehicles being more than 90% effective in terms of saving lives. And so as these autonomous vehicles come to market, it will likely be millions of lives saved. So that will be a very important, exciting development. We're already seeing generative AI being used in a lot of these autonomous vehicles. The last is around climate change. And I know, we're obviously in the middle of a huge fire in Los Angeles, which my heart goes out to a lot of the folks that have been affected. And if you think about climate change, 4 billion people get affected by climate change. And so that's a huge magnitude of the population in the world. And what you're realizing is the rate to measure climate change is really looking at icebergs and the rate of change of those icebergs melting. That's the way to really think about climate change. So there's a research institution that's actually using generative AI recently that's been able to, instead of humans measuring the rate of change of these icebergs melting, which obviously takes a long time, they've been using generative models that have recently come out, and they're able to reduce the amount of time to look at these icebergs melting 10,000 times faster than a human. So these are just 3 use cases, and I believe that, again, we're just at the starting point. We'll start to see this year a lot more of those use cases come to fruition. And I'm sure you guys have all seen something like this in terms of large language models and in terms of where we are with those models being whether it's at a preschool level, whether it's at an elementary school level with GPT-3, whether with GPT-4 when it was introduced, it was similar to a smart high schooler, and now with reasoning, with GPT-01, reasoning agents, which are just as effective as a PhD student. And I believe we're the biggest inflection point of these frontier AI agents is yet to come. So what does that all mean? AI agents, I believe, are going to be the next frontier. It's, I'm sure, what we've been hearing a lot about at CES. But what that requires is exponentially more compute than what we've seen before. And so if you look at the power implications of that, what we're seeing is, if you just look at 2022, and some of the training that was done, the training costs, and then the power required, we were in the megawatts. Then you look at 2024, and you basically had 100 million megawatts of power, which is equivalent to 100,000 homes. You look at 2026, and we're now going from megawatts of power to gigawatts of power. And what that equates to is basically the amount of energy required is that in order of a magnitude of the Hoover Dam or a large nuclear reactor. And that's just 2026. And so we've all heard about, where AI is headed. Now you look at 2028 and 2030. In terms of the magnitude, we're now going from gigawatts, 1 gigawatt, to 10 gigawatts, to then eventually 100 gigawatts, which in 2030, that's going to be equivalent to 20% of the US electricity production. So huge amounts of compute required. And the implications are there's going to be a huge amount of power required in order for us to go forward with what we need to do with generative AI and making sure that that's mainstream and more pervasive. So what we like to talk about is AI is on a collision course with reality. You really need to think about high performance in order to power kind of the next generation, the next wave of reasoning, and whatever the next frontier is after that. But you also need to think about low power. And so here are some headlines that were published last year. By 2030, global data centers will consume more power than all of India. So just think about the magnitude of the problem in terms of what we need to think about, but at a chip level, at a software level, at the data center level, and even beyond. And so that's what I'll have Sy and Dion come up and talk a little bit about. What are they doing within Meta and NVIDIA to really impact change here? And the reason why this is if you look at GPT, and this is just one of many examples, ChatGPT requires 15 times more energy than a typical search, which is 2 times an increase in the power usage every 100 days. And that's equivalent to 43,000 US households. And eventually, it will be 3 times the total power grid. So you can see the impact and the magnitude of the problem. Not only are we going to increase compute, the demands for compute are going to increase, but the power implications of generative AI and these reasoning agents is really going to create a tax on our power grid. So we really need to think about how are we going to impact change to scale where we need to go with AI going forward. I like to talk about no power, no AI, and I think we're really going to see the fundamentals of some of this transition happen. And I think we really need to rethink everything, from the chips itself, thinking about low energy, high performance, to the data center, whether it's liquid cooling, to beyond the data center, whether it's nuclear reactors or whatnot. And so that's what we'll talk about today. Right now, I'd love to bring up Sy and Dion to have that conversation with me. And let's talk a little bit about what we're doing as a partnership and as an ecosystem.
Sure. All right.
Great setup there.
Thanks for having us.
Yep.
Yeah. No, thank you guys for joining us. Why don't you guys introduce yourselves first? Tell a little bit about who you are, what you do at your companies.
Yes, so I'm Dion Harris. I'm the director of our data center operations or solutions team. And so a lot of what I spend my time is really sitting at the intersection of both of those two key trends that Ami highlighted, right? We have the intense growth in demand and all the promise that AI unlocks in terms of new solutions and use cases, but you also have how do you do that responsibly? How do you do that in a way that you can grow sustainably and make sure that you're meeting the demand as responsibly as possible? So I kind of sit in between both of those two, sort of mega trends, trying to really figure out and do the calculus of how we optimize our solutions around those.
Hi, everybody. My name is Sy Choudhury. I support all of our AI partnerships at Meta. That's a variety of different components, but the parts that are interesting here is that the areas around what we're doing around large language models. Many of you have heard of Llama, which is the moniker was large language model meta AI, but now it's turned into a fuzzy, cute animal like every open source project should have. But also, in addition to the models, we do a lot with the ecosystem, including NVIDIA and ARM, on the tooling that actually executes these models, that trains these models. This is a set of tools called PyTorch. And so we'll talk a little bit more about what we're doing there as well.
Great. Thank you guys for joining us. It's been a great partnership across all three of our companies. I talked a little bit about the trade-offs between energy performance or energy efficiency and model performance. How do your organizations navigate this change?
I think what's becoming more and more clear, and as you start to look at how AI is being adopted, not just sort of explored and sort of looked at from a research perspective, but really adopted and deployed in enterprises and research institutions, it isn't a one-size-fits-all approach. And so you recognize having, an array of options, meaning small, medium, large, basic, moderate, advanced, is really going to be sort of the approach that I think will make the most sense, because, a model that's being used for, clinical diagnosis of diseases needs a different level of accuracy and efficacy than your customer service model that's giving you the latest, sort of sports stories. So understanding that each organization, each user, and each use case has its own, unique requirements around that trade-off of how accurate does the model need to be, how intelligent does the model need to be, versus how much resources does it consume, whether it's cost, energy, power, et cetera. So I think that is really at the core of how we approach it, is how do we create, sort of an enough selection such that it gives them the flexibilities to adopt it.
So do you make those trade-off considerations when NVIDIA is bringing out these new platforms to market?
Absolutely. So here at CES, we actually announced a couple of things that were really rooted around some of these same trade-offs. So for example, if you saw the keynote on Monday, Jensen highlighted our new assortment of Nemotron models. And basically what that is, it's taking the Llama open source model and looking at all the underlying hardware dependencies and how do we optimize the model to be deployed in our data centers. So we made sure that when we looked at it, we didn't say, okay, let's just go and tackle the large, multi-node use cases, because we recognize that those are challenging. But we also said there's lots of people who are doing research that's on desktops and edge devices. And there's also some who are doing single GPU based implementations. And so we announced Nemotron across 3 different platforms or 3 different model sizes that would really speak to that. And that really is reflected not just in the software, but also there's underlying hardware solutions that help support those as well.
And we announced together Digits, which was great, which is, another platform. Do you want to talk about Digits?
Absolutely. And so Digits, I loved it. If you saw the keynote or if you just looked at social media in the last couple of days, you'll see what looks like a miniature DGX box. But the whole point of that is getting to what I was describing before, is recognizing that there's a whole spectrum of activity that's happening in terms of AI research. And so Digits basically takes a processor that's based on our Blackwell technology, tightly coupled with an ARM CPU, and it provides the same, sort of power of the platform, if you will. So all the software that we develop in terms of, all the optimizations that we do within the actual platform to run on Llama, to run all the various models, are baked into our hardware that we're making available for researchers. And this device is literally about a petabyte of performance. So you can literally deliver what used to take a supercomputer on your desk. And I'm using my fingers to describe it because it literally is this big. And so understanding that, this is the type of solutions that will definitely be required and be useful for everyone to really embrace and figure out how they can leverage and deploy AI.
Great. Sy, how are you thinking
Maybe
about
I can add to I totally agree that there will be different models for different use cases that are at different sizes. And when we develop Llama, one of the customers of Llama is ourselves, right? And we have many, many different use cases at Meta where we're actually using generative AI, right? There's the Meta AI agent, this consumer agent that everyone's familiar with, but we also are using it in our ads tools. We're using it as a coding assistant. We also use it in business messaging type of products, et cetera. And so it's not a surprise that in the Llama 3 family, which is kind of the second wave of releases that we had of Llama last year, that we have a slew of models, right? We kind of in the main line, we have the 8B and the 70 billion parameter models. And each one of those, if you think about it, a 70 billion parameter model can run on a H100 in the data center and do some really amazing stuff like drug discovery. But the 8B, you can run 4 of those on the H100 and actually have 4 streams to be able to do that customer service bot you talked about. We've released even a bigger one, a 405B. You now require actually 16 H100s. So clearly it's not something you would run in real time, but you could use it for offline tasks, batch processing, synthetic data generation. And on the other end of the spectrum, we released a 3B and a 1B. 3B very much focused on what you can do on a PC type of platform, or definitely on a digits platform. And then a 1B for embedded in your app in a mobile phone. Now, there's, we from Meta's perspective, we don't develop and release these models just because, hey, it's cool to release all these different sizes. Each one of those has a purpose-built outcome, and they are actually mapped to the processing power that's available for inference at that time. So we work very, very closely. Interestingly, this is totally by chance. I'm not saying this is because of the plug. We literally map a lot of our decisions to what's NVIDIA coming out with next, because their chips are going to be used primarily for inference in the data center, and what's ARM coming out with next, because their chips are what's going to be used primarily for edge devices, right? Simple as that.
How do you think about the scaling challenges? So obviously you guys have large language models at the large end, like you mentioned, and then the small language models. How do you think about the scaling, and it relates to power efficiency based on what we just discussed earlier?
Yeah, so I think there's 2 trends that are helping us in the world for the challenges you talked about with energy. The first is the capabilities of these models, generation to generation. I think everybody understands and knows this, are increasing at literally like a 2-to-1 from a model size, which you can kind of equate that to the cost in power and performance to run this, to the capabilities. So if you looked at as a good example, Llama 2, 70 billion parameter equivalent, the Llama 3, 8 billion parameter model is more capable 9 months later than what we released 9 months previously. And so we're seeing this, and we expect this to actually happen with Llama 4 that we're training right now as we speak, that every 9 months we're going to get a huge benefit in scaling efficiency. Now, that's the good news. The bad news is all of us know that we are deploying more and more generative AI use cases. So thank God that these scaling efficiencies are coming, because they'll essentially be made up or taken up by the fact that you're just going to do inference a lot more. Right?
Yeah. There's a lot of talk right now about test tuning. And are you guys using AI-driven optimizations for energy efficiency and looking at using AI to help with the energy problem?
So, when we look at sort of how we approach sustainability at NVIDIA, there's really 3 key areas that we focus on. First is how can we make our platform as efficient as possible, so that, in addition to making the models themselves more effective and more accurate and intelligent, the underlying hardware is getting, more efficient. And so we have lots of data points that describe, how we've done that. And of course, we talked a lot about how Blackwell itself is going to sort of advance the state of the art in terms of overall efficiency. The other key area that we try to focus on is how do we bring these technologies to bear to be a solution? And so you mentioned climate as one of the key areas that will hopefully benefit from AI. We have a project called Earth 2, which is literally taking all of our core simulation platform, all of our core AI capabilities and visualization, and enabling the entire climate tech ecosystem to help accelerate and advance research in those areas. And then, of course, as it relates to the grid, I think that's one of the main sort of concerns is as the data center workloads grow and as the power requirements increase, how can our grid keep up? And so I was just at a session yesterday in Palo Alto talking with a number of energy executives describing how can we leverage AI to improve the integrity, reliability, and scalability of the grid. And so there's a huge emphasis I think in the next couple of years, understanding that this wave is coming,
Right.
how can they leverage these tools like AI, like digital twins, like all of these sort of, cutting edge technologies to improve the hardware infrastructure that supports a lot of the grid. So I'd say that's really how we're thinking about it, driving the efficiency of our platform, improving the overall research that drives innovation around climate, and then hopefully, creating more solutions, whether it's the grid hardening, renewable energy research, a lot of things along those lines.
Yeah, if I could add to that, I want to switch gears a little bit from Meta as a technology provider of Llama to Meta as I think many of you know, we are a hyperscaler in ourselves. We run most of our own data centers. We design and run our own data centers, and so then that's not just for training; it's for inference. And of course, we have a lot of users in the world using the family of apps, including WhatsApp, Facebook, et cetera. And so, top of mind is power efficiency when we are doing inference on any model, right? And if I might switch gears a little bit from LLMs. The models that we run mostly if you look at the overall scale, are recommendation models that serve you up your feed, serve you up ads, right? That's our business model there. And recently we announced an initiative with ARM and NVIDIA to take our recommendation models, part of our recommendation models, and move it to a new architecture. And that's actually using the Grace ARM chip, the GB200 chip from NVIDIA. And this project was called Andromeda. We had a blog about it in late December. You guys can look online about it. But the whole goal of Andromeda was, how do we take our ads recommendation models and make them more efficient? And the reality for that was, the way to do that is use some of these latest technologies like the GB200 chip and deploy that. And this is something that we're now in the early stages of deploying. Now, why are we doing that? The main reason we're doing that is because just like every other hyperscaler or cloud provider that maybe many of you work with, we're running out of power. And so we have to get more efficient even ourselves as a consumer of those models when we are deploying our services to keep our business alive.
And I just want to sort of piggyback that point a little bit to say that Meta is not alone in that perspective. And I think one of the key things that we look at, like I said, sitting at the intersection of seeing the growth in demand and seeing sort of the realities of limited power, most data center operators are figuring out, how do I get the most out of my power envelope? Like, what technologies are available? Because you can't just go spin up another data center. You can't just add more load to the grid in a year or even 2 years time frame. So in order to keep up with demand and really take care of the business, we're often working with a lot of our customers and partners to figure out, of the technologies that are available, how do we maximize that power envelope? Knowing that you can't grow it, like a hockey stick. Even though we know the demand is growing, you have to be much smarter about how you leverage your infrastructure to deliver that workload. So that's where we spend most of our time working with a lot of our customers and partners.
Yeah, that's a great point. So, Sy, I think one of the interesting things about what you guys are doing is you develop models for yourself. So as you mentioned, Meta releases these models, but you consume them as well. So you are a data center user, whether it's at the chip level, the software level, beyond. What are you guys doing within your own data centers in terms of this power efficiency problem? I mean, we talked about at the chip level, but are you doing things beyond? I mean, liquid cooling is obviously top of mind for many people here. What do you think is sort of that next inflection point?
I think that there's multiple ways we're trying to address this. One is pick the right chip for the job, because not everything requires the highest end chip. So we are much more discreet about which chip and which interconnect that we have for different workloads. The second is, I think, Dion, what you're talking about, basically retrofitting our current infrastructure with more efficient infrastructure, and most of that is the chips, including, of course, with liquid cooling. And the third layer is around making sure that we have the most efficient software tools that run these models, right? And so this is where PyTorch comes into play, and to make sure that PyTorch can not only do very efficient execution of the model, and then in the near future, even distributed execution of the model, as these models are getting better, and even moving some of the execution to the edge, meaning your own personal phone or laptop device, in order to have a kind of a distributed inference approach. So when most people think about distributed inference, you might be thinking about, well, you're actually doing inference on, two GPUs on the infrastructure. But we will soon be getting this year into efforts where we'll be doing some of the inference of the model embedded in the app versus on the data center itself. And so we're taking an approach that's by necessity. We're taking an approach that involves hardware decisions, decisions on actual retrofits, as well as the software tooling and infrastructure around PyTorch.
Do you think about different use cases? And like you mentioned, I mean, there's obviously many use cases that Meta has. Do you figure out what use cases are going to balance that performance efficiency problem?
Yes, yeah. The data center team actually has budgets and quotas for different workloads for the different teams internally. And of course, a lot of this is also not just LLM, right? There are recommendation models. I mean, if you're working at a company like us or similar, recommendation models are a significant portion of our workload, and they're very different kind of power envelope and memory bandwidth envelope than what an LLM is. And so there are different even decisions in the data center that we make for the different model types.
And Dion, I mean, what do you do? Because I know at NVIDIA, you guys obviously work broadly across hyperscalers, even tier 2 clouds like CoreWeave, et cetera. What are you guys thinking about? What are you hearing?
So there's a couple of things I'll speak to. Your initial question around the data center and what we do with our own data centers, because NVIDIA is very much a practitioner of the technologies that we build and design. In other words, we're not making a self-driving car, but we build a self-driving car training platform, and we have car solutions that we're actually fine-tuning and building, not to sell them, but just to fully understand the problem and solution as we're creating them for our customers and partners. So when we build supercomputers, like our latest platform, we're currently building our Blackwell-based supercomputer. And so that forces us to really be empathetic to our audience and our customers and partners in understanding when you build and deploy these solutions, what it takes and requires. But in that process, we're also being very sort of introspective in trying to understand what learnings can we codify, share with our partners and broader community. So all of our engineers, as we're deploying Blackwell, for example, we're looking at all of the CDU vendors. We're engaging with them, giving them firsthand feedback around deploying some of these solutions to drive the performance and efficiency. And then more importantly, we're codifying that and sharing that with the broader ecosystem. We were just at the OCP session earlier this year. We're in 2025, so it was last year. We were just at OCP in October, and it was really great to see sort of this broader collection of the data center ecosystem sharing all this information. We basically open sourced a lot of our Blackwell architectural elements to the broader community. So, I guess what I would say, we're active practitioners in terms of building and deploying these technologies. We use a lot of models internally for our chip development, for our internal processes. And through that, we try to codify and share that as much as possible to make sure we can drive more efficiency.
Do you think we need to change things at the policy level at all? How do you think government needs to get involved?
I think one of the things that we're seeing is that, interestingly, industry is getting involved as it relates to the world of power, and maybe that's healthy because a lot of public utilities historically have not had a lot of investment, or had investment that's lagging as far as lagging in a time frame from what the power needs would need to be. And now you have essentially for-profit companies getting involved. And many of you have read about the efforts from Amazon, Meta, and others, the folks building data centers, to actually forecast ahead and try to address kind of these power needs. Because I think we know that without that, the innovation that Ami, you talked about, the scale. Well, first and foremost, the scale in training these large language models are increasing at exponential rates, right? And whether you think it's because of it's for innovation, it's for national security, it's for developing new interesting use cases, that just training these models are going to be a very power hungry effort. But even more important is all these use cases that right now a lot of us see the digital native companies companies like Meta, companies like LinkedIn, TripAdvisor. If you look at them, there's lots of cool agents, and like you can get your trip summarized, etc. So the digital native companies have come out and are using Gen AI everywhere. What happens when the rest of the Fortune 1000 is using Gen AI everywhere? That there's some significant, and many of them are doing proof of concepts, but they're just starting to actually ramp, and so we haven't even seen the tidal wave. And so getting ahead of this, whether it's by government led initiatives or industry led, is absolutely critical.
And I think we've seen it from a slightly different perspective. And we've had meetings with lots of government officials across the world, both U.S. and abroad. And across the board, most of them truly understand this is a transformational opportunity, right? And so you hear the term sovereign AI has sort of evolved as a thing now. In other words, national AI factors are being built across every country because they recognize in order to enable their labor force, in order to accelerate the innovation within healthcare, manufacturing, all of these industries that are core to their fundamental, sort of livelihood as a nation, it becomes a strategic imperative. And so I think what's really interesting, you have this cross-section, like I sort of started out my description of my overall role, which is incredible opportunity and also incredible challenge in terms of how do you get the right resources in place to make sure you do it as efficiently as possible. So I do believe that there is a role for government to play there, and we're seeing a lot of governments taking an active sort of seat at the table to try to understand how do they shape and define it. And so, NVIDIA has been always very open to that and engaging with a number of different sovereign entities to make sure that they can harness the power of their data to kind of realize the potential of AI. So to your answer to your question, absolutely. I think government does have a role to play.
Yeah, I don't think it's going to be one company that's going to be able to change this paradigm. I think it's going to require the ecosystem of all of us, the energy providers, the government, collectively to really think about the problem more holistically. I talked about AI agents being the next frontier. I know Jensen talked about this at his keynote. Do we need to think about things differently from a power consumption perspective? I mean, do you think about reasoning and compute being exponentially more needed for reasoning in the new age of reasoning? Is there a one-size-fits-all approach? How do you think about it, Dion?
So I think there's, an incredible opportunity, because I think what we've seen is through some of the reasoning models that have evolved, there is a huge opportunity to improve the intelligence and efficacy of some of these models during inferencing if you can create, sort of these reasoning or chain of thought based models. However, it does force you to now think about how can you leverage the underlying resources much more efficiently, how can you use smaller models where you can and need to. Because in these agentic frameworks and agentic workflows, it often involves multiple models working in concert to solve a task. And so through that, you have to really start to compartmentalize the model use case and the resources required. And so I think we're at the very early stages of this, quite frankly. But there's a lot of interest and excitement because there's so much promise and there's so much capability that's being demonstrated through some of these models.
Yeah, maybe I could add to that there's actually more, when we through our activities with Llama, we end up talking to a lot of different enterprises and large and small companies alike, and a lot of the companies are actually kind of aligning to the fact that in addition to the fact that the models are getting better and the reasoning within the models and the planning and the I'll call it step-by-step instruction following or agentic workflow. Different people have different names for the same thing, but it's basically the same thing. So the models are getting better. That's right? But what's happening now is really a realization that that as a entity, as a product and engineering team within a company, if you're solving a solution, you're not just going to throw a model at it. It's just not a model. There is a software engineering aspect that is now coming back alive, which is, hey, we're going to have maybe an initial model that actually understands the context of what the user is trying to do, then calls in either a large, medium, or small model to actually execute that context, or maybe even does some RAG to get some additional information, et cetera. And so this system architecture is something that we're seeing move forward. And I think that will actually not only help with, I'll call it reasoning and planning in a different way, not at the model level, at the system level, but it will also help in the power efficiency because the right model is going to be called by this orchestrator model, I'll call it that,
Right.
for the right job.
Yep. So switching gears a little bit of a fun off the cuff question. How do you use AI in your daily life? What are you excited about for 2025 that you've seen, either companies that you've seen that you're excited about or specific use cases? Either one of you guys want to take this?
I'm almost ashamed to admit this, but I've become so reliant on Perplexity that it stuns me sometimes when I realize how often I'm going to it to just to sort of probe and understand certain issues, topics, etc. So I think the large language models are front and center. My daughter, I was playing a game with her the other day and realized that there's an actual an AI agent at play in some of the online games, and so it's pervasive to the point that whether you're using it, sort of overtly or using it indirectly, you're using it every day. And as you mentioned, as I go on Meta and I'm looking at my friends' feeds, and you recognize all the technology that's serving that up is driven very much by AI. So, but if I had to throw out one guilty sin, it would be Perplexity is one that I kind of go to often.
Great.
Yeah, maybe I can answer it in two ways.
Sure.
One is that I think the world of I'll call it search is an intent, right? And so the world of search is completely changed because I use Perplexity, I use Meta AI a lot because it's easy to use and right in front of me type of thing. And so, and at the end of the day, a lot of times I'm actually searching for information. So that's the way we're going to interact with these, I'll call it query tools is changing. And that's been one of my my main use cases as well. But separately, a little plug for our friends at Spotify who've moved essentially are in the process and completed moving all their use cases over to Llama. They did a blog about this, but I love the fact how their AI DJ is actually understands what I'm doing because there's contextual information. It actually starts to explain why it picked these songs, not just like throws these songs at me. Wow. And so I love the AI DJ feature within Spotify. And so that's the second thing I would add. The thing, what excites me for the future is, or for this year, not the future. The future would have been like last year. Right. So is what's gonna, whether it's Meta with Llama or some of the other technology providers, we are on the cusp of implementing and rolling out these next generation multimodal models. And, everybody is familiar with the fact that there are multimodal models out there, but many of them, under the hood, the best way to think of it is Lego blocks that have like a language model with, let's say, an image or a speech model bolted on. They're very effective, and they work pretty well. But what you can't do is you can't, for example, be talking to it, throw a text string at it and a picture at the same time for the model to then react. You will not do it at the same time because there's still a linear execution of those three models, etc. What we're on the cusp of is multimodal models that are truly, truly multimodal and will essentially mimic, perhaps, we think, right, more of how our brain works, because we don't actually just like look at something and think and hear something separately. We actually kind of synthesize all this and then react or make a decision, etc. And so I think we're at very early stages of what innovation is coming out there. It'll be the true multimodal V1, I think, will be only the beginning, but there's still a lot of really interesting use cases that are going to get unlocked by what we are going to see in Llama 4 and other models this year.
Great. Yeah, I know when I was walking the show floor yesterday, there were things like an AI pillow, which I was like, wow, better night's sleep, an AI pillow. Or there was another gadget around gentleman who couldn't communicate verbally. So he had a headband that was AI driven, which was all trained on his voice. So when he twitches his eyebrow, he could actually say yes or no, and it would communicate the response in his own voice. And so those were some of the things I noticed while I was walking the show floor. And so, like you said, we're just at the beginning of what's to come. Last 20 seconds. Anything either of you guys want to add as we close out? Obviously, high performance, low power will be at the heart of everything. It will require a paradigm shift. It will require all of us to think differently at the chip level, the systems level, the software level, the data center level, as we talked about. So anything you guys want to add on closing?
I think you nailed it. I mean, we're really looking at everything from the chip to the grid and figuring out how we can optimize at all layers to make sure that we can deliver, to meet all these incredible, use cases and deliver against all this potential, but do it, in a way that's sustainable and responsible as possible. So.
Yeah, maybe I'll just add to that, not because it's open is necessarily, obviously we're big and Meta on open technologies, but it will actually, we'll only get there through a collaborative effort, call it open or not, right? What you mentioned, OCP, which is really open compute platform of how to make these hardware components work really efficiently, but modularly. There's the tools layer, like with PyTorch, which is contributed by contributions from ARM, NVIDIA, Meta, and many others. And then at the model layer, things like Llama. And so these things, openness kind of captures more the community collective effort of companies. Totally. That's how I think we're going to actually make these efficiencies and gains.
Great. Well, thank you both for joining me. Hopefully we'll be joined next year on stage and we'll have a lot more to talk about in terms of power efficiency. Thanks.
Thank you, Alma.